the derivative and tangent line problem. We already talked about the tangent line problem-ish. And what is that problem? Tangent line. We're trying to find what of a tangent line? Slope. And slope corresponds with rate of change. And rate of change, slope at one point. Why is that a dilemma?
2 points.
We always need 2 points for slope. Rise over run. y2 minus y1 all over x2 minus x1. That's the way it's been done since forever, except it's not good enough. Technically, if we were in our book, which my book is here somewhere, in your section 2.1, it actually says that when calculus was first developed, around the beginning of the 1600s-ish, by the 1700s, poor Keith now stepped on his foot. There were 4 main questions that European mathematicians were trying to work on. The tangent line problem, velocity and acceleration problem, minimum maximum problem, and the area problem. And you're like, wait, you said there were 2 main problems. There are 2 main answers that answered all 4 of the main problems. Maybe I should put it that way. But the answer to the tangent line problem answers velocity and acceleration, answers minimum and maximum, and then in a sense sort of answers area, but that was his own little deal. He was a bit more complicated. But anyway, just in case you guys do check out the section, because there's a lot of good information in there. If you did see that, I didn't want you to be confused by, you said there were only 2. Well, there are 2 problems with answers that basically answered the rest. Okay, so when we're talking about slope of a tangent line, slope of the graph at one point, or otherwise known as instantaneous rate of change, which is velocity, we call this the derivative. However, in Calc 1, whether it's college level, high school level, or I don't know what other level there would be, if someone remembers their education in calculus, they're like, oh, limits, derivatives, integrals. Those are the 3 things they're going to remember. And limits, maybe they don't remember. But if you say something, they're like, oh, yeah. Limits, derivatives, and integrals. So limits, we talked about for a chapter. We're going to kind of talk about for another section here, and then section at the very end. Yeah, the very end of all of our derivative learning concept, introduction, notes, etc. around chapter 4 or 5. But that was it for limits, besides a little bit in integrals, but not much. Now on to derivatives for about 2.5 chapters, and that might stretch out into like 3 to 4 tests. Okay, so derivatives, big deal. A lot going on, and technically some would say half a calculus. Slope of a tangent line, slope of the graph at one point or instantaneous rate. However, this is the verbal description, not the definition. This is the verbal description, not the definition. If I was to ask you for, Charlie's fine, he's not doing this forever quiz. If I was to ask you for the definition of continuous, what would you guys say? They're done with their forever quizzes. We're allowed to do this now. What's the definition of continuous? A function is continuous at x equals c if the 3 conditions are met, which are
f of c is defined.
f of c is defined, or the point exists.
X approaches c.
The limit as x approaches c of f of x exists, and
The limit as x approaches c of f exists as f is equal to f.
equals f of c, aka they agree. Another way of saying it, the limit as x approaches c from below of f of x equals the limit as x approaches c from above of f of x equals f of c. Okay? The limit. Did you put IDP?
I put the
Okay, I'll give you something just for like knowing something. Okay, come back. But if I were to ask you the description of continuity, that's what some of you put in your forever quiz when you had no idea what the definition was. What's a description of continuity?
There's no holes.
No holes, but that's not enough.
No f.
No vertical asymptotes, that's true, not enough. Continuous for all real x values is, it's kind of like a circular reasoning because you're defining it in terms of itself, but drawing it and not picking up your pencil, that's a description, right? No holes, no breaks, no jumps, no vertical asymptotes. Those are all descriptions. This is a very, very informal way of describing a derivative. However, a derivative is the slope of a tangent line, is the slope of the graph at one point, is the instantaneous rate. But the definition, a little bit more complicated.
Miss Lee, could you like dual page it for a little bit?
Oh, here it is. Can you guys see it if I dual page it?
Yeah.
Sort of. Let me pull it down. The definition. A description gives you the idea of what it is, of how it's used, how it's applied, etc. The definition gives you what it truly is at its core, how it's solved for. What are the conditions that have to be met? Doesn't just describe it, defines it. And the reason I'm making a big deal is because some of you guys have not learned how precise you need to be, aka the difference between a description and a definition. All right, the description of the derivative, all things we need to keep in mind, and all different directions of different exercises, applications that we need to be able to link back to a derivative. But the definition itself, we did a group exploration. It was on those teal papers, turquoise papers, whatever. And you guys drew a secant line. And then you made a closer secant line and a closer secant line. Why am I saying secant? Because they were lines that did what? Passed through the graph at how many different points? 2. And you guys found lots of slopes, rises over runs. Why were we having those secant lines, the 2 points, get closer and closer and closer? What were we trying to approximate? The tangent line, right? And we were able to look at those slopes and see what they approached. The answer to the tangent line problem is that we need to take the limit as delta x approaches 0. Delta x means change in x, aka how far apart the 2 points that we're finding the slope of the secant line with. As that distance goes to 0, as the lines get closer and closer, or I should say the 2 points of the lines get closer and closer to 0, we figure out what's going on with the slopes. And the slopes are found by y2 minus y1 over x2 minus x1. Now this doesn't look that easy because we have to keep it general. We have to keep it able to be applied for whatever points are being used. And remember, we didn't want to be restricted to having to draw all these different lines and find all their different slopes the long way and then see what it's approaching. There's an easier way. And the first way to summarize that is with a limit. Because we've just talked for an entire chapter and took a test, most of us, on how to solve limits. So if we can generalize the problem and say, sweet, we're talking about slope. So the y value at the point of tangency plus a certain distance away. So the y value at a removed point minus the y value at the point of tangency all over however far it is or has been removed. This is a slope of a secant line, and as that delta x goes to 0, where if the limit does exist, the derivative exists. Hence the last part of the definition, provided the limit exists for all x for which the limit exists. Ooh, there should be a period. And some of you are like, wait, what? There we go. Provided the limit exists. The limit doesn't exist, the derivative doesn't exist, so therefore, there is no slope? Interesting, we'll talk about that. Probably tomorrow, though. Better. For all x for which the limit exists, f prime, remember f apostrophe we talked about in our summer package just a little bit, f prime is a function of x. Now this easier notation down below, what is it meant to do? Help those of you that are like this delta x, I've always hated him ever since pre-cal. So we can let h equal delta x. We're not losing any meaning because we still have stated who this truly is. But we can go ahead and make it look a little bit prettier because we have a separate variable in there that we know not to combine with x in the sense of making it squared or something like that.
Is this a forever card?
Uh-huh. And this is our forever number, aren't we on 6?
Yeah.
Now, quick word of the wise. Am I boxing the delta x and the h? Yes. You technically only have to know one. However, if you like the h1 better, you have to have this statement. Okay? You technically don't have to have them both. I'm boxing them both, letting you know that you can do a choice, or you can put them both on the card. But if I was to have a quiz, the wording is important, and then you have to have one of those formulas. And just to show you what else is important, there is one thing I should have written and I didn't. So let me take one more second. This was a question on a forever quiz, a forever quest, a forever test, or a forever final. What? We have all those? Yep. We do, by the end of the year. If this was on a forever quiz, quest, test, or final, you would need the derivative of a function f is given by, provided the limit exists, pretty much. You would need f prime of x, not kidding, I take off if it's not there, equals, and you need either the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x, or let h equal delta x, and f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Just trying to make it clear for you guys what you need to know. Once again, forever card number 6. We got one. It's right at the beginning of a new chapter. Good day. Katrina, we good with page 1, kid?
Yeah.
Everybody else, we good with definition of derivative? Okay. Pause. Because you guys have seen this in your summer packet, let's just take a second. Let's do a couple examples. Before I get into variations of this problem, we'll just say, find the derivative. It could be technically stated 2 different ways, using the definition. I can spell. Or a little double-sided arrow to be like, hey, it's the same thing, using the limit process. If these are the directions, it means to use the limit as delta x or h approaches 0, and to actually find the derivative using a limit. So let's go ahead and do some examples. Meaning, in order to find a derivative, we have to have some sort of beginning function. We're going to do x squared minus 3x plus 10. Let's go ahead and do f of x is equal to the square root of 3x plus 1. Now, oops. Calibrate my board. Some of you think that you have a shortcut way of solving number 1. And just a few of you think you probably have a shortcut way for solving number 2, for finding f prime of x, the derivative of f. Quick heads up. I would almost be willing to bet money on no one getting number 2 right using any of the simplistic rules that we've done. Almost willing, because there are probably just a few of you that are like chain rule, and I don't know how you know that, but you might. But number 1, a few of you could get right. So I want you guys to take a second. I want you to think power rule. This was a bonus on the summer review quiz at the beginning of the year. It was in our summer packet. You've done this before. I want you to go ahead and write down what you think f prime of x is. This isn't going to count as your work, but it is a great way of checking. And don't show anyone, don't tell anyone. If you remember the power rule, something comes down, something subtracts. And you guys saw your summer review quizzes. And some of you got this right and some of you did not. Didn't you see them? Have you not seen them? Oh, let me get those back to you. They've been graded for a while. Make a hypothesis as to what you think the derivative is. You have about 30 seconds. And then we're going to solve it using the definition and see if you guys are right. There are two different common mistakes, if you even know the power rule, that are frequently made until you have it solid. And many of you don't yet. But go ahead and write down. What do you think it is? Something comes down, something subtracts 1. What do you think the derivative is? Go ahead and write it down real quick. Make a hypothesis. Okay, now let's go ahead and solve it. Using the definition of derivative. The limit. What do you guys like, delta x or h? Okay, so we'll do let h equal delta x. Or maybe a better way of saying that, delta x equal h either way. Doesn't matter. The limit as h approaches 0 of, what's the first part of that formula, guys? What comes next?
F of x plus h.
Yeah. So f prime of x equals, he's the derivative, right? It's all about notation. We'll talk more about notation today / tomorrow. But f of x plus h. F of, does that mean times or does that mean plug in?
Plug in.
Plug in. So I'm going to go ahead and for f of x plus h, plug in, some of you function notation has never been your friend, but hopefully we worked on it a lot last year. Hopefully it's better. Is that f of x plus h? Check it out. Remember, f of x plus h. X plus h is what is in the argument. So it takes the place of each of the locations of the input or the independent variable. If this was like an online form, it would be a gray box that you're supposed to fill in, and you can fill in with one thing, two things, or mathematically you can fill in with 1 term, 2 terms, 3 terms. But we have to fill in with parentheses to properly get everything in there. So f of x plus h, and quantity squared of the input, minus 3 times the input, plus 10. That's only half the formula. What comes next? Minus f of x. Question. What just went wrong? I didn't distribute the negative, so if I didn't distribute the negative, what do I have to put in? Parentheses. In homework, I've been trying to give you problems that say find the error. We have to be precise with our work or else we're going to make so many little mistakes. All over h. What would happen right now if we were to plug in, and it always happens with a difference quotient? That'd be x squared minus x squared. That'd be minus 3. If I plugged in, h is 0. That'd be minus 3x and plus 3x, plus 10 minus 10. Uh-oh, I have 0 over 0. It's going to always happen with the difference quotient. We got to keep going. So then plugging and chugging, aka simplifying, because we tried to plug and chug, it didn't work. So we have to do some simplifying. Don't kill a puppy. What do I mean? Foil the x plus h. And we get x squared plus 2hx plus h squared minus 3x minus 3h plus 10 minus x squared plus 3x minus 10. Hopefully I just made that look easy. But how many of you have ever made a mistake in any homework, quiz, or test on a negative? Right? Probably, somewhere. Beware, beware, beware. Then, what cancels? Hopefully, everything without an h. But I'm not good enough. I'm not far enough. Remember, if we're trying to keep going, there's a discontinuity that we need to factor out and hopefully cancel. What am I able to pull out of everything at the top right now?
H.
An h. So I'm going to go ahead and say f prime of x is equal to, Brandon, can you open the door for Keithan? 2x plus h minus 3. Nice. I'm still not done, but I'm so close, I can. Yeah. Since the h has been factored out, that is more than legal to cancel. Some of you have been obstinate and not been rewriting your limit, and so you're like 2x plus h minus 3. Yay, and you're wrong. How do we finish the problem?
Plug in
Plug in 0, and we get
2x minus 3.
how many of you got it right to begin with? A few. How does the power rule work? It's not technically till the second section. And in your homework, when it says find the derivative in section 2.1, you are using the limit definition. We need it for the AP. Please, please, please don't shortcut yet. But you can check. What happened to the 2? It comes down. What happens to the power of x squared?
Decreased by 1.
2 minus 1. Decreased by 1 is 1. Minus. Power of 1 comes down. 3 times 1 is
1. 3.
3.
Oh my god.
Decreased by 1. 1 minus 1 is 0. X to 0 is gone. What x power is next to the 10?
X to the
1.
Or 0, my bad.
X to the 0.
Oh, yeah, times 1.
So bring down the 0. 10 times 0 is 0. The derivative of any constant is 0. Why? The slope of any constant is 0. Oh, that'll be a rule for next section. But anyway, power rule would have gotten it. Now, hold on. We have another one. Why am I doing examples? Because I want some of you guys to be able to start on homework tonight. It's going to take a little bit of time. And we'll go through some more of like the actual terminology, yada, yada, yada tomorrow. But, on problem number 2, some of you can make a guess, just don't do it. Question, what would f of x plus h, what did I just forget? Find the error, yeah, find the limit. Limit as h approaches 0. And technically, who's h? I don't know. Let h equal delta x. Okay, what would f of x plus h be? This is one of the most common mistakes in plugging in. F of, where do I put the input? 3 times x plus h plus 1. You guys see my f of x plus h? Okay, minus, who comes next? Oh no, plug in, it's 0 over 0, keep going. Struggle. How do I keep going with the square root? I wish we'd learned that.
Conjugate.
Conjugate. Who's the conjugate? Well, he's not pretty, but he's there.
Close.
And what I do on top, I have to do on?
Bottom.
I'm warning you. You're not going to be able to do this until like the end of this chapter. Like actually solve with a shortcut rule. So right now, all you've got is the limit definition. But what happens when, give me a couple seconds, what happens when we multiply a square root by a square root and we don't forget our parentheses? The square roots cancel. I end up with just 3x plus h plus 1. A negative times a positive is a negative. Careful, keep the parentheses. Both of those square roots cancel. Hey, I can do stuff now. Exactly. We leave the bottom the way it is, hoping that that little h will soon cancel if I can just simplify correctly. For tomorrow. Finish that puppy up and see if you can see what the derivative is. He's a hard one to find with the shortcut rule, but he's not too bad. We just use our limits. Get out of here, cool kids. Thank you for the extra 30 seconds that you gave me. Anyone who turned in their spiral, come get it after school. Start homework tonight. But you have tomorrow to finish. It'll be online by lunchtime.
What day did they say plug the
Chapter 2.
was?
Tomorrow. In Zuck's room during lunch. Tomorrow somewhere during lunch.
Who's starting club?
Brandon.
What time are we starting, Brandon?
I don't know yet. That's
He's
what
still
it is.
pondering. I'm sure there'll be an announcement tomorrow as well. Just plan on tomorrow lunch.
I want to make a
Bye,
student
guys.
union this week.